The universe is full of rules, rules written in the language of mathematics and physics. Gravity tells a planet how to dance around its star. It dictates how dust and gas clump together to form new worlds. We thought we had a pretty good handle on these rules. We built models, we made predictions, we looked out into the cosmic ocean and saw our theories reflected back at us again and again. But the universe, in its infinite majesty, loves to surprise us. It loves to present us with things that defy our neat little boxes of understanding. It reminds us that our rule book is a work in progress, a draft that is constantly being revised by new discoveries. Imagine a planet so far from its parent star that it almost seems adrift. A lonely wanderer in the cold darkness of space. A world so massive it blurs the line between a planet and a star. A celestial body whose very existence throws a wrench into our most fundamental theories of how solar systems are born. This isn't science fiction, this world is real. Its name is HD 106906b, and it's a beautiful, wonderful, maddening puzzle. Every great discovery begins with a single observation, a flicker of light, an unexpected wobble. In 2013, a team of astronomers was using the powerful Magellan telescopes, nestled high in the arid Atacama Desert of Chile. They were peering at a young star system, just 15 million years old, a mere toddler in cosmic terms. Our own sun, by comparison, is a middle-aged 4.6 billion years old. The astronomers were hoping to learn more about the early chaotic days of solar system formation. They were looking for the faint heat signatures of planets, the leftover warmth from their violent creation, using an instrument designed to block the blinding glare of the central star. What they found was astonishing. There in the data was a faint but distinct point of light. It was incredibly far from the young, bright binary stars at the center of the system. At first they had to be sure it wasn't just a background star, a random object photobombing their observation from much farther away. To confirm it was a companion and not a coincidence, they had to track its movement. They watched and they waited. They found that this faint object was moving through space along with the central stars. It was gravitationally bound. It was a planet. The team, led by Vanessa Bailey at the University of Arizona, had stumbled upon one of the most bizarre exoplanets ever found. The discovery was made possible by a technique called direct imaging. This is incredibly difficult. Finding a planet next to its star is like trying to spot a firefly hovering next to a searchlight from miles away. To understand how strange this planet is, we need to get a sense of its address in the vastness of the Milky Way galaxy. The star system, HD 106906, is located in the direction of the constellation Crux, the Southern Cross. It's about 336 light-years away from Earth. A light-year is the distance light travels in 1 year, which is nearly 6 trillion miles. So the light we see from this system today started its journey back when Galileo was first pointing his telescope at the heavens. The system itself is a binary. That means it has not one, but two stars at its center. These two stars are locked in a gravitational embrace, orbiting each other closely. They are young, hot, and about 1.5 times the mass of our sun. Around these twin suns, astronomers have detected a disk of dust and debris, the raw material from which planets are born. This is what we expect to see in a young system. It's a planetary nursery, a construction zone where gravity is pulling together cosmic rubble to form new worlds. But this is where the picture starts to get very, very strange. The planet, HD 106906b, orbits its parent stars at a mind-boggling distance. It is more than 730 times farther from its stars than the Earth is from the Sun. Let that sink in. Our most distant planet, Neptune, orbits at about 30 times the Earth-Sun distance. The Kuiper Belt, a vast ring of icy bodies where Pluto resides, extends to about 50 times that distance. This planet is more than 14 times farther away than the edge of our own known planetary system. It lives in a realm of its own, a cold and lonely outpost in the far reaches of its solar system. At such a colossal distance, the light and heat from its twin suns would be feeble. From the cloud tops of HD 106906b, its stars would appear as little more than two incredibly bright stars in the sky, not the life-giving suns we know. The gravitational pull would be incredibly weak, a mere whisper compared to the firm grip our sun holds on its planets. This extreme separation is the heart of the mystery. It's what makes HD 106906b a scientific enigma. The planet is so far out that it seems to be hanging on by a thread, challenging the very laws that should have governed its birth and its journey. The puzzle of HD 106906b deepens when we consider its other characteristics. It's not just its distance that's strange, it's also a behemoth. This planet is massive, weighing in at about 11 times the mass of Jupiter, our solar system's own giant. Jupiter is so big that all the other planets in our solar system could fit inside it. Now, imagine a world 11 times more massive than that. This places HD 106906b in a celestial gray area. It skirts the upper limit of what we call a planet. A little more massive, and it would have ignited nuclear fusion in its core, becoming a brown dwarf, a failed star. This combination of immense mass and extreme distance is what breaks our models of planet formation. The leading theory, known as core accretion, works beautifully for planets like Earth and even Jupiter. It says that planets form from the disk of gas and dust surrounding a young star. First, small particles of dust and ice stick together, growing into larger rocks, then into planetesimals, and finally into a solid core. Once this core becomes massive enough, its gravity starts pulling in huge amounts of gas from the surrounding disk, forming a gas giant. This process is a race against time. It has to happen before the young star's radiation blows all the gas away. The problem is, at 730 times the Earth-Sun distance, the protoplanetary disk would have been far too thin and sparse. There just wasn't enough raw material out there for a core to form and grow to the colossal size of 11 Jupiters, and even if there were, the process would be incredibly slow. The orbital period at that distance is thousands of years long. The building blocks of the planet would have moved so slowly that they wouldn't have had enough time to collide and grow into a giant planet before the disk of gas and dust dissipated. Core accretion simply fails to explain this world. It's like trying to build a skyscraper with only a handful of bricks and a few minutes on the clock. Faced with a planet that defies conventional formation theories, astronomers had to get creative. They had to think outside the box, or in this case, outside the neat, orderly plane of a typical solar system. One of the leading ideas is that HD 106906b is a planetary exile. The theory goes like this. The planet formed much closer to its twin stars, in the bustling, crowded inner region of the protoplanetary disk where there was plenty of material. It grew big and fast, just as our models would predict for a gas giant. But, the early days of a solar system are a violent, chaotic place. Imagine a game of cosmic billiards. Young planets jostle for position, their orbits crossing and their immense gravity pulling on one another. In this scenario, HD 106906b may have had a close encounter with another massive object, perhaps another giant planet, or even one of the central stars. This gravitational tussle could have acted like a slingshot, flinging the planet out of its comfortable birthplace and into the cold, distant exile where we find it today. This planet-planet scattering model is a strong contender because it explains both the planet's mass and its current improbable location. It suggests a dramatic and violent past for this distant world. Another fascinating and even more exotic possibility is that HD 106906b isn't a planet in the traditional sense at all. Perhaps it's a failed star from a different system. This theory proposes that the star system formed as a triple system, not a binary. Instead of 2 stars and a planet, there were 3 stars trying to form. However, the gravitational dynamics were unstable. The smallest of the 3 stellar embryos failed to gather enough mass to ignite into a true star. It was then kicked out of the central stellar nursery, but not with enough force to escape the system entirely. It settled into the strange, distant orbit we see today. This idea is compelling because it neatly explains the planet's enormous mass. It didn't form like a planet from the bottom up, it formed like a star from the top down, through the direct collapse of a gas cloud. This would make it less of a sibling to the other planets and more of a failed twin to the central stars. Distinguishing between these 2 scenarios is one of the most exciting challenges for astronomers. The answer lies hidden in the planet's orbit and the structure of the surrounding debris disk. To truly grasp the sheer oddness of HD 106906b, it helps to bring the scale back to our own cosmic home, the solar system. Our system is a place of relative order and predictability. The planets orbit the sun in the same direction and on roughly the same flat plane, called the ecliptic. This shared plane is a fossil record of the spinning disk of gas and dust from which the planets were born. It's a key piece of evidence for the core accretion theory. The planets are like skaters moving in the same direction on a vast flat ice rink. Now let's place HD 106906b into this picture. First, its distance. Neptune, our farthest known planet, is about 2.8 billion miles from the Sun. HD 106906b is over 68 billion miles from its stars. If our solar system were the size of a dinner plate, with Neptune at the rim, HD 106906b would be in a house down the street. It is profoundly isolated. The gravitational influence of its stars is tenuous, making its long-term stability a fascinating question. It's a world living on the edge, both literally and figuratively, far beyond the cozy confines of a traditional planetary system. Then there's the orbit itself. Using data from the Hubble Space Telescope over a 14-year period, astronomers were able to track the planet's slow, majestic crawl across the sky. What they found was that its orbit is highly eccentric and inclined. It's not a neat circle on a flat plane. Instead, it's a long, stretched-out oval, and it's tilted at a significant angle relative to the debris disk surrounding the central stars. This is another major clue. An orbit like this is not something that happens gracefully. It's the hallmark of a violent past, strong evidence for the cosmic billiards or gravitational scattering theory. It's as if our skater was suddenly knocked off the rink and is now circling far above it at a strange angle. Comparing its mass is just as striking. Jupiter, the king of our solar system, has a mass of about 1/1000th that of the Sun. HD 106906b, at 11 times Jupiter's mass, is a true heavyweight. Its mass is about 1% of its host star's combined mass. This is a much larger ratio than what we see between Jupiter and the Sun. This again points away from the standard planet-building process and toward something more dramatic. It's a world that stretches our definitions and forces us to imagine a universe where the lines between planets and stars can be wonderfully blurred. When a discovery as profound as HD 106906b is made, the scientific community buzzes with excitement and debate. Paul Callis, an astronomer at the University of California, Berkeley, noted the peculiar nature of its orbit. His work using the Hubble Space Telescope helped confirm that the planet's path is misaligned with the main debris disk. He suggested that this is a snapshot of a nascent solar system that has undergone a powerful gravitational disruption. Meiji Nguyen, also from UC Berkeley and the lead author of a key study on the planet's orbit, put it beautifully. She said the system is a spectacular example of a planet that has been scattered into an external orbit. The data, she explained, tells a story. It's as if we have a time machine for our own solar system, going back 4.6 billion years to see what may have happened when our young solar system was dynamically active, and everything was being jostled around and rearranged. Robert de Rosa, of the European Southern Observatory, highlighted the complexity. He remarked on the possibility of a flyby from a passing star that could have perturbed the system, or the lingering gravitational effects of a planet that has since been ejected entirely. The system's debris disk is also lopsided, suggesting something has stirred it up. As de Rosa put it, the disk is asymmetric, which is a smoking gun for a past gravitational disturbance. These expert opinions converge on a single, powerful idea: solar systems are not born in peace, they are forged in chaos. The story of HD 106906b takes an even more intriguing turn when we look back at our own solar system. For years, astronomers have been puzzled by the strange orbits of a handful of small icy bodies out beyond Neptune in the Kuiper Belt. These objects, known as trans-Neptunian objects or TNOs, are clustered together in a way that statistics say they shouldn't be. Their orbits are all tilted and pointed in roughly the same direction, as if they are being shepherded by the gravity of a large unseen object. This has led to the tantalizing hypothesis of a Planet 9. This hypothetical Planet 9 would be a massive world, perhaps 5 to 10 times the mass of Earth, orbiting the Sun on a long, eccentric and inclined path, hundreds of times farther out than Earth. Sound familiar? The proposed characteristics of Planet 9 bear an uncanny resemblance to HD 106906b. Suddenly, the bizarre world 336 light-years away doesn't seem so alien. It looks like a possible blueprint, a proof of concept for the very kind of planet that might be lurking unseen in the dark frontiers of our own solar system. Astronomer Mike Brown of Caltech, one of the main proponents of the Planet 9 hypothesis, has pointed to this connection. The existence of HD 106906b demonstrates that the universe is capable of making such planets. It shows that the mechanism required to get a planet into such a strange orbit, gravitational scattering, is a real and plausible process. Finding HD 106906b was like finding a piece of a legendary creature that people had only speculated about. It tells us that our hunt for Planet 9 is not a wild goose chase. We are searching for an object that has a known analog elsewhere in the galaxy. HD 106906b is more than just a planet. It's a cosmic question mark. It stands as a monument to our own ignorance and a beacon for future discovery. Every time we think we have the universe figured out, it presents us with a puzzle like this one, forcing us to go back to the drawing board. This is the heart of science. It's not about having all the answers, it's about a relentless, joyful, and humble search for better questions. This single, distant world has expanded the very definition of what a planetary system can be. It has shown us that the tranquil clockwork of our own solar system might be the exception, not the rule. The discovery challenges us to rethink the story of creation for all planets. Are chaotic, violent beginnings the norm? How many planets are wandering exiles cast out from their home systems to roam the galaxy as lonely orphans? How many systems harbor a distant massive guardian like HD 106906b, or our own potential Planet 9 shaping the architecture of the system from afar? These are no longer just philosophical musings. They are concrete scientific questions that we now have the tools to investigate thanks to worlds like this one. It has opened up a whole new field of possibilities. The implications are profound. If planets can be tossed around so easily, it changes our search for life in the universe. A planet ejected into a distant cold orbit is unlikely to be hospitable, but the same chaotic dynamics could also send a small rocky world from a system's frigid outer edge into its warm, habitable Goldilocks zone. The universe is a dynamic, ever-changing place. The story of HD 106906b is a powerful chapter in that grand cosmic narrative, a story of violence, exile, and improbable survival. It reminds us that the map of the universe is still being drawn, and so we look up at the night sky with a renewed sense of wonder. We know that among those billions of stars, there are countless surprises waiting for us. There are worlds that will defy our expectations, break our models, and expand our minds. HD 106906b is just one of them, a tantalizing preview of the discoveries yet to come. It tells us that the cosmos is rich with possibilities we have not yet dreamed of. And the glorious unending search for our place in the cosmos, continues. The universe awaits.